Okay, so in this lesson we'll be learning how to differentiate polynomials, and here's an example of a polynomial. For example, x squared plus 3x plus 1, that's a polynomial, and the notation that we use to say that we want to differentiate it is that you put a dx in front of it, and the thing that you want to differentiate you put in brackets, and then you put the answer over there. So this is a polynomial, but we're going to first learn how to differentiate monomials. And monomials are polynomials that only have one term. For example, this is an x to the 5 that has one term. This is a polynomial because it has 3 terms. So if it has 2 or more terms, it's called a polynomial. If it only has one term, like that, or 6x cubed, it's called a monomial. And we first learn how to differentiate monomials first. So here's the first rule that we're going to learn. If you want to differentiate x to the n comes down and multiplies the x, and then you minus 1 off the power. So that becomes an n minus 1. And that's it, that's the rule. We're not going to prove it. Initially we're just going to learn the rules, learn how to differentiate, and later on we can prove things. So as an example, if you want to differentiate x to the 5 comes down, and then you minus 1 of the power, becomes a 4. Okay, and if you want to differentiate x to the 7, the 7 comes down, and minus 1 of the power, the 7 becomes a 6. That's the first examples. The next is that if there's a number in front of the term, all that happens is the n comes down and multiplies the a. So here we get na, and then you still minus 1 of the power, x to the n minus 1. And we can do that on this. So if you want to differentiate 6x cubed, the 3 comes down, multiplies the 6 to give you 18, and then you subtract 1 of the power. Next example, we differentiate minus 4x squared. So the 2 comes down, multiplies the minus 4, and then you minus 1 of the power, gives you x to the 1. Now usually a power of 1, we don't normally write the 1. So I can simplify this as minus 8x. And normally you would go from here straight to this step. There's no need to write a power of 1. Okay, the next example, we have a fraction in front of the term, and that doesn't make any difference. The 7 will come down and multiply the 1/3. So we're going to get 7/3 x to the 6. In this example, we have a decimal, 2.3x cubed. So the 3 comes down and multiplies to 2.3 to give you 6.9 x squared. And even if there's a third, a root 5, the 8 comes down and multiplies to root 5. So 8 root 5 x to the 7. The 8 becomes a 7. And here we have a pi in front. And a pi is a transcendental number, but it doesn't make a difference. The 4 will come down and multiply the pi. So you have 4 pi x cubed. Okay, and if you notice in some of these I have brackets and some of them I don't. It doesn't, if you're dealing with monomials with one term, you don't actually need a bracket. The reason why I put brackets was just to make it a bit easier to read, but you don't need brackets on monomials. But if you have a polynomial, something with more than one term, you have to put a bracket around it. Okay, next we're going to differentiate linear terms. And a linear term, if I just do a polynomial, x cubed minus 4x plus 5. The linear term is a term that has the x without any power, so that's called the cubic term. It has a cube, and that's the constant term, but the linear term, or the x term, is minus 4x here. And let's see how to differentiate it. So here's the general linear term. What we're going to do, we know that anything to the power of x, x to the power of 1 is x, so anything to the power of 1 stays the same. So we can actually put a little 1 on this x, and it doesn't change anything. But now we can use the previous rule that we had. So the 1 comes down and multiplies the a to give you a. Then you have x, and then you minus 1 of the power gives you a 0. And then anything to the power of 0 is always 1. So this is just a times 1. It's an a. So the derivative of ax is just an a. The x cancels, becomes a 1. And in general, when you're differentiating, you can miss out all these steps. You just go from here directly to here. So if you wanted to differentiate 4x, it's just 4. If you want to differentiate minus 7x, it's just minus 7. And if you want to differentiate x, the answer is 1. And we do have to be a little bit careful, because there's a common mistake. Sometimes people put a 0, because it looks like here that the x is disappearing. If it disappears, then you think, well, if that goes, it must be a 0. But it's not actually disappearing, it's turning into a 1, because x can be written as 1x. So you can see if you have 4x, it becomes a 4. If you have 1x, it becomes a 1. So make sure you don't put a 0 when you want to differentiate an x. And here we want to differentiate 3/4 x, and that just becomes 3/4. Okay, next we're going to now differentiate the constant term in a polynomial. So if I was to do a polynomial again, the constant term is the term that doesn't have an x. So that plus 5 is the constant term. It's also called the number term. And the rule is when you differentiate, it just becomes 0. But let me just show why it becomes 0. So we know that x to the power of 0 is 1. Anything to the power of 0 is 1. So on this we can actually add a little x to the 0. So here we wanted to differentiate the constant c. I can add an x to the 0 here, and now I can use the rules of differentiation. The 0 comes down, multiplies the c to give you 0, times, and then you minus 1 off the power, so that becomes a minus 1. But now 0 times anything is always 0. So the derivative of any constant is always 0. And in general, you miss out the intermediate steps. You can go straight from here to 0. So if you wanted to differentiate the number 7, it becomes 0. Differentiate the minus 12, it becomes 0. And if you want to differentiate root 6, so root 6 is a third, but that's just still a constant. It's just a number. So it's 0, and 2 pi is also a number, a constant. There's no x here, so when you differentiate it, you get a 0 still. Okay, now we're ready to begin differentiating actual polynomials. So these have more than one term. And the rule is that we simply differentiate each term one by one and put a plus or minus. So equals, so x to the 5 comes down and you minus 1 of the power, give you 5x to the 4 plus the 4 comes down, multiplies the 3, gives you 12x, and you subtract 1 from the power. Then you have a minus, the 3 comes down, and minus 1 of the power, minus the 2 multiplies the 6 to give you 12, and the 2 becomes a 1, which we don't write. Then the 4x, the plus 4x, that's a linear term, so that just becomes 4, and the minus 9 is the constant term, and that just becomes 0, which we don't write. Okay, so before we go into the examples, we just have to talk about the different notations that we could have for differentiation. And we're going to do 4. There'll be 4 types. The first one we've already seen, so I can just do this example. So this d by dx of x squared minus 5x plus 3 means you want to differentiate this polynomial. So x squared becomes 2x, minus 5x becomes minus 5, and the plus 3 becomes a 0. So that's one we've already met. But instead of given this, we could be given in xy notation. So this is the same question, but they've given like this, and one way to denote differentiation would be dy dx. So we say dy dx or dy by dx, and then we just differentiate it. Okay, another way, instead of dy dx, you can just do a y dash. That also means that we want to differentiate this. So that's y dash. Also, we can say y prime sometimes as well. And then if we're given the same question in function notation or fx notation, we say f dash of x or f dash x, and then we can differentiate it. And we can also say f prime x as well. Okay, example number 1. We're given a polynomial y equals x to the 4 plus 5x cubed minus 4x squared minus 7x plus 8, and we have to find dy dx, so we have to differentiate it. And here we just differentiate it term by term. So we have dy dx equals, now the 4 comes down and minus 1 of the power, plus the 3 multiplies the 5 to give you 15 x squared. The 2 comes down, multiplies the 4 to give you minus 8x and 1. Oops, didn't mean to write that. And then the minus 7x, that's the constant term, becomes minus 7. And the plus 8 is a constant term, that becomes 0. Okay, example number 2. We're given a function in fx notation, and we need to find f dash of x, so we need to differentiate it. But this example is a little bit different from the previous examples, because we have a bracket here. And the method is that we must first expand the bracket to get a polynomial, then we can differentiate it. But before we do that, I'm going to just, there's a mistake that we could make. You might think, if you're given this, why don't we just differentiate it term by term, and then we have the answer. That's going to be the incorrect method, and I'll actually demonstrate that now. So if the incorrect way, so we want to make sure we don't do this this mistake. You might think that we can do f dash of x and differentiate 2x squared gives you 4x. Then open the bracket, 3x squared becomes a 6x, and the minus 4x becomes a minus 4, and the plus 1 disappears. And if I just expand it, just so we can see what it looks like, here we have a 24x squared and minus 16x. So this is going to be the wrong method. So I just want to say what we did here. We differentiated first. And then we expanded. So that's the wrong method. We don't want to do that. You're meant to expand it first and then differentiate it. So let's see the correct way. So here, f of x, because we're not yet differentiating, we're just expanding. We have a 6x to the 4 minus 8x cubed plus 2x squared. And now that it's been expanded, we can now differentiate it. So the 4 comes down, gives us 24x cubed minus the 3 multiplies the 8, gives us 24x squared, and the 2 multiplies the 2 gives us 4x. And this is the correct way. And you can actually compare. That's not the same as that. Different answers. So here we expanded first and then we differentiated. Okay, example number 3. We're given a double bracket and we need to differentiate it. So the first step is that we'll expand the brackets. So d dx, that's a 4x squared. Say minus 20x plus 3x is minus 17x and minus 15. Okay, now that it's been expanded, we can now differentiate it. So 4x squared becomes 8x, minus 17x becomes minus 17, and the minus 15, the constant term, becomes 0. Okay, example number 4. We're given a function here, and we need to find y dash. We need to differentiate it. And we can see that there's some brackets, so we can't differentiate it straight away. We need to expand the brackets and then differentiate. So let's do that. So here we need to cube all of this. So the 3 acts on the 2, it cubes the 2. 2 cubed is 8. And then the 3 must cube the x squared, so you multiply the powers, so that gives you x to the 6. And here we need to square the 7 and the x. So we have 49x squared. And now we can differentiate. So y dash, 6 multiplies the 8, 48, x to the 5. The 2 multiplies the 49, 98x.